If you rewind 380 million years and go for a swim, I don't think people truly understand that you would probably last less than 5 minutes before being devoured by something completely terrifying. I used to tell my mom when I was a kid that I wished so hard that I could wake up one day and be alive during the dinosaurs. But oh man, I had no idea. 380 million years ago, the Devonian. Beneath the surface lurks a creature unlike any modern fish, a predator so heavily armored, so powerfully jawed, that paleontologists have dubbed it a prehistoric armored tank. Meet Dunkleosteus, a genus of placoderm fish whose fossil remains suggest it was among the most formidable apex hunters of its day. Measuring up to 8 to 10 meters, 25 to 33 feet in length, Dunkleosteus wasn't just large, it was built for raw power. Its skull and thorax were sheathed in thick, bony plates, forming a protective exoskeleton reminiscent of medieval armor. Instead of conventional teeth, this fish bore sharp, bony blades that formed a formidable jaw mechanism capable of shearing flesh and possibly smaller placoderms in a single snap. By exploring Dunkleosteus' world and morphology, we'll see how it became a top predator in the so-called Age of Fishes. We'll delve into how scientists reconstruct its bite force, how these creatures interacted with other marine life, and what the fossil record says about their eventual demise. From head to tail, this armored tank that swam helps us understand the evolutionary experiments of the Devonian seas, an era that forever changed the course of fish evolution. Before unveiling Dunkleosteus in detail, it's vital to understand the Devonian period, spanning roughly 419 to 359 million years ago, often called the Age of Fishes. During this time, Earth's oceans teemed with new fish lineages exploring open niches, from early sharks, chondrichthyans, to the heavily armored placoderms and the bony fish ancestors that would eventually lead to modern teleosts. The continents, arranged differently, included large landmasses like Euramerica and Gondwana, while shallow epicontinental seas covered vast stretches of land. In these shallow seas, marine life flourished. Corals built early reefs, arthropods like giant sea scorpions, eurypterids, hunted smaller prey, and ammonoid cephalopods soared through the water column. But the Devonian was also a dynamic time geologically. Over millions of years, changing sea levels, climate fluctuations, and evolving ecosystems shaped competition among species. Some fish groups developed external bony armor, particularly the placoderms. This extensive front body armor provided defense against predators in an era lacking major marine reptiles or large marine mammals, none of which had evolved yet. Placoderms as a group encompassed many forms, from small bottom dwellers to gigantic apex hunters. Dunkleosteus was among the largest and most imposing. Fossils predominantly come from what's now North America, especially the Cleveland Shale in Ohio, but related taxa spanned multiple ancient seas. That environment was a shallow marine setting replete with nutrient influx, supporting thriving ecosystems and inevitably fierce competition. By the late Devonian, ecosystem pressures escalated, culminating in significant extinction events that reshaped marine biodiversity. Dunkleosteus, which rose to prominence earlier in the period, found itself at the center of these changing ecological webs. In short, the Age of Fishes was a golden era for fish diversity, setting the evolutionary stage for major leaps in predatory design. Dunkleosteus's robust jaws, protective armor, and large size exemplified a winning formula in these high-stakes Devonian seas, at least for a while. Placoderms were a class of prehistoric armored fish that thrived throughout much of the Devonian. Their hallmark feature was a series of bony plates covering the head and thoracic region, leaving the posterior body relatively unarmored. This external shielding evolved as a defense in predator-rich environments, but many placoderms became formidable predators themselves. Within placoderms, Dunkleosteus belonged to an order called Arthrodires, which typically had a jointed neck region, allowing them to lift their head shields and open their jaws more effectively. While many Arthrodires measured under a meter, Dunkleosteus soared to lengths of up to 8 to 10 meters, dwarfing most fish of its time. Some paleontologists separate Dunkleosteus into multiple species, Dunkleosteus terrelli being the most famous. The bony plating on the head formed thick, interlocking plates that offered both protection and a robust anchoring structure for the jaw muscles. The plates weren't typical scales, but were specialized dermal bone that grew around the skull and neck. Where smaller placoderms might rely primarily on these plates to avoid predation, Dunkleosteus used them offensively, housing a jaw mechanism that could generate terrifying bite forces. Key arthrodire traits included a hinged articulation between the head and thoracic shields, letting the jaws gape widely. In Dunkleosteus, this hinge was well developed, enabling a lightning-quick jaw snap. If most fish adapted stealth or speed to evade predators, Dunkleosteus faced few serious threats beyond its own kind. The entire placoderm lineage eventually vanished by the end of the Devonian, leaving behind tantalizing evidence of the bizarre, often monstrous experiments in fish evolution preceding modern lineages. The phrase armored tank immediately conjures images of heavy plating. For Dunkleosteus, the most striking aspect was indeed the thick cranial armor encasing its massive head and front torso. Fossils often preserve these large bony plates, which had distinct edges that paleontologists can piece together like a puzzle. Each plate varied in thickness and shape, collectively forming a formidable shield around the fish's vital areas: brain, gills, and major blood vessels. Below the armored region, its body likely tapered into a muscular tail. Unlike modern fish with intricate scale patterns, Dunkleosteus's unarmored posterior might have borne cartilage or minimal scale coverage, though direct fossil evidence for the tail region is somewhat limited. In some relatives of Dunkleosteus, we see tail fin designs suggesting a strong, possibly symmetrical or semi-lunate tail, implying decent swimming speed. Positioned near the top of the food chain, Dunkleosteus didn't need subtle camouflage. Instead, it utilized raw power. Strong jaw musculature anchored to the dermal plates gave the head an almost bulldog-like silhouette. Many reconstructions show the fish with an upward slope from the tip of the snout to the dorsal ridge, culminating in a broad head shape. Eye sockets typically appear somewhat small relative to the head shield, possibly indicating a reliance on short-range ambush or sensing vibrations rather than super acute vision. One particularly fascinating feature is that Dunkleosteus lacked conventional teeth. Instead, the edges of its jaw plates form self-sharpening blades. Over time, the bony edges wore against each other, maintaining razor-like edges. By combining a protective exoskeleton with powerful biting structures, Dunkleosteus effectively balanced offense and defense, allowing it to dispatch prey while safeguarding itself in a predator-heavy environment. Perhaps the most sensational aspect of Dunkleosteus is its jaw mechanism. Modern biomechanical studies suggest that Dunkleosteus could open its mouth extremely quickly, creating a powerful suction to draw prey inward. Then the closing force, thanks to robust jaw musculature, was enough to tear through bone or heavily scaled prey. In 2006, a study by Dr. Philip Anderson and colleagues used fossil jaw reconstructions to estimate that the largest Dunkleosteus species might deliver a bite force exceeding 5,000 newtons, over 1,100 pounds of force at the blade's tip, comparable to modern apex predators like alligators or large sharks. The jaw geometry, with two pairs of rotational joints, meant that Dunkleosteus could open its jaws in as little as 20 milliseconds, generating a quick vacuum effect. This combination of speed and brute force is rare. Modern fish often excel in either suction or biting, but few approach Dunkleosteus's dual mastery. These bony fangs, albeit toothless, formed scissor-like shearing surfaces. The upper and lower jaw plates slid along each other, slicing through flesh in a manner akin to a huge pair of pruning shears. While direct evidence of its prey includes smaller placoderms, arthropods, and even quick-swimming fish, it's plausible Dunkleosteus could overpower almost any creature in its environment, short of a similarly sized or larger arthrodire. The savage synergy of vacuum feeding and sheer jaw strength underscores how Dunkleosteus became a terrifying oceanic presence. In a Devonian world with fewer protective shells or scaly armors advanced enough to block such force, a single bite likely spelled doom for many prey species. Dunkleosteus didn't thrive in the open ocean's deep expanses as far as we know. Instead, it inhabited coastal and epicontinental marine basins, places teeming with fish, arthropods, ammonoids, and early sharks. Its formidable weaponry naturally positioned it as an apex predator. In these nutrient-rich seas, smaller placoderms and bony fishes scoured reefs or silt floors for food, while cephalopods roamed open water. Dunkleosteus likely patrolled the mid-water columns or near the seabed, ambushing prey with short bursts of speed. Some paleontologists speculate on whether Dunkleosteus was a solitary hunter or if it congregated in areas flush with feeding opportunities. Certain modern apex predators, like great white sharks, are mostly solitary, converging only around abundant food sources. Dunkleosteus might have exhibited a similar pattern, though no direct evidence of group behavior, such as mass death assemblages, has definitively emerged. Another open question concerns its relationships with other large placoderms. In some strata, broken Dunkleosteus armor plates show bite marks consistent with attacks from individuals of the same species. This hints at possible intraspecific combat, maybe territorial disputes or competitive feeding. If so, these interactions underscore the harsh environment of the Devonian seas, where even top-level predators risked mortal combat with their own kind. Despite dominating the local ecosystem, Dunkleosteus also faced hazards. Giant sea scorpions or large sharks might have harassed juveniles, while older individuals risked malnutrition if they outgrew local prey supplies. But for a period in Earth's history, no marine animal better symbolized unstoppable might than the heavily armored Dunkleosteus. One reason Dunkleosteus has become so iconic is the rich fossil trove found in the Cleveland Shale Formation in Ohio, USA. These deposits date to the late Devonian, 370 to 360 million years ago, preserving extensive remains of arthrodires, including well-articulated skull roofs and thoracic armor of Dunkleosteus. Excavations from the 19th century onward brought spectacular skull plates to museums, where their size and structure astounded paleontologists. Though North America yielded the most famous Dunkleosteus finds, related placoderms appear in Devonian strata globally. Some species, once lumped under Dunkleosteus, are now reclassified into separate genera, reflecting the complexity of arthrodire taxonomy. Nonetheless, the genus stands as the prime example of giant, blade-jawed placoderms. In many fossils, the head and thoracic region are the best preserved parts, since the rest of the fish, lacking thick ossification, disintegrated. This partial preservation complicates reconstructions of Dunkleosteus's tail shape and fin arrangement. Nonetheless, paleontologists rely on comparative anatomy with related arthrodires and occasional partial postcranial fragments. Ongoing fieldwork occasionally uncovers new arthrodire specimens, sometimes surpassing previous size records or showing morphological quirks. Each discovery refines our understanding of how these top-tier predators lived, hunted, and eventually perished in Earth's ancient seas. Though separated by hundreds of millions of years, certain parallels can be drawn between Dunkleosteus and modern marine apex predators, great white sharks. In terms of feeding style, the high bite force and opportunistic predation echo some aspects of large sharks. Great whites also rely on swift ambush tactics, but they differ drastically in skeletal makeup, cartilage versus Dunkleosteus's bony skeleton, and in the presence of true teeth rather than bony jaw blades. Saltwater crocodiles. Big crocodilians share robust bite power and an armor-like hide. However, Dunkleosteus's body plan was decidedly more fish-like, with fins and presumably a tail for propulsion, whereas crocs rely on lung-based respiration and surface ambush. Killer whales, orcas. Orcas represent social, intelligent hunters, whereas Dunkleosteus likely lacked advanced social structures. Yet their respective apex statuses reflect a parallel. Lacking major predators themselves, they shaped community dynamics in their ecosystems. Ultimately, the idea of a heavily armored fish with a near unbreakable jaw arrangement has few true modern analogs. Marine ecosystems have drastically transformed, yielding new types of apex predators. But Dunkleosteus remains a striking illustration that evolutionary strategies once included forging a fish so shielded and so lethal that it would have overshadowed many of today's top-tier ocean hunters, at least in raw, biting ferocity. Around the late Devonian, Earth underwent a series of extinction pulses, sometimes grouped under the late Devonian mass extinction. These events didn't occur as abruptly as, say, the end Cretaceous asteroid impact, but they spanned millions of years, gradually reshaping marine faunas. Placoderms, including Dunkleosteus, bore the brunt of these shifts, disappearing entirely by the dawn of the Carboniferous, 359 million years ago. Hypotheses for the Devonian die-offs include global cooling or anoxic events, marine anoxia, lack of oxygen, impacted reef-building organisms, and large fish that relied on well-oxygenated waters. Competition. Evolving bony fishes, actinopterygians, might have begun outcompeting placoderms in certain niches, though direct evidence is debated. Habitat disruptions. Fluctuating sea levels and climatic volatility starved some shallow basins of stable conditions crucial for large predators. By the time the Devonian ended, the once dominant placoderms vanished. Surviving fish lineages took different evolutionary directions, leading eventually to modern sharks, rays, and bony fishes. Dunkleosteus, along with the entire placoderm branch, remains a prime example of how success in one epoch can't guarantee survival if global ecological upheavals escalate. Few prehistoric animals spark such immediate awe as Dunkleosteus, a behemoth fish sheathed in thick, bony armor, wielding jaw blades, capable of slicing through anything in its domain. Existing in the fabled Age of Fishes, it rose to apex status in shallow Devonian seas, overshadowing most rivals through evolutionary innovations that combine defense with lethal force. Fossil evidence, particularly from the Cleveland Shale, reveals a predator that likely hunted swiftly, opening its mouth in fractions of a second, then delivering a crushing bite with enough power to crack arthropod shells or lesser placoderm plates. Despite this success, Dunkleosteus and its placoderm kin ultimately vanished in the late Devonian mass extinctions. Their disappearance cleared the path for modern fish lineages to ascend, reshaping aquatic ecosystems for the remainder of Earth's history. Yet the fossil record preserves enough clues to reconstruct Dunkleosteus's imposing silhouette, its formidable jaws, and the environment it once dominated. Modern apex predators, from great whites to orcas, showcase nature's continuing pattern of forging top-tier hunters. Dunkleosteus stands out as a testament that such roles once belonged to an entirely different lineage, one that blended the archaic with the fearsome, yielding a living tank that was the envy and terror of Devonian seas. In short, Dunkleosteus exemplifies the raw creative might of evolution, proving that even millions of years ago, life on Earth engineered creatures that challenged our imaginations and reigned supreme in their watery kingdoms.